We know that metals and non-metals are very important for us. Let's look at some of the physical properties of the metals and non-metals. You can associate the physical properties of metals with the most common metal that you must have seen, gold. Coal or carbon is a metalloid, but it shows properties similar to the non-metals. So we generally regard coal or carbon as a non-metal. So you can associate the properties, the physical properties of non-metals with coal. So now let's look at the physical properties. The physical state. What is the physical state that we see the metals in? Gold, silver. These things, you've seen that they generally exist in the solid form. So at room temperature, the physical state of the metals is solids. So the metals are generally solids at room temperature, except the only metal, mercury. Mercury is the only metal which is present in the thermometers that is in the liquid state. So there is only one metal in the liquid state, which is mercury. Rest all metals exist in the solid state at room temperature. What about the non-metals? The non-metals, if you consider coal, it is in the solid state. Other non-metals like sulfur, phosphorus in the solid state. But gases like oxygen gas, nitrogen gas, chlorine gas, these are all non-metals in the gaseous state. So the non-metals at room temperature, they are generally solids or gases, with the only exception of one non-metal, which is bromine. Bromine at room temperature is liquid in state. So for metals, there is only one exception, mercury, which is in the liquid state, and for non-metals, there is only one exception, bromine, which is in the liquid state. What about the luster? Luster is the shine present on the elements. So we've seen that the ornaments that we make, they are generally made of gold and silver. Why? Because they have a shine on them. The copper utensils, they also have a shine. So the metals generally are very lustrous. That is, they have a shine on them. That is why we use them for making ornaments. It is because of this that gold gets its symbol Au from the Latin word aurum, which means shining dawn. So aurum, it means shining dawn, which shows that the metals have a luster. Now what about non-metals? You must have seen coal. Does it shine? No. It has a very dull appearance. So non-metals, in general, they have a dull appearance. So other non-metals like sulfur, phosphorus, the non-metals, all these non-metals are generally dull looking. Hardness. Now if you associate this with the metals that you must have seen, gold. So you know it is generally hard and strong. So metals are generally hard and strong. For example, gold, silver, platinum, all these metals are generally very hard and strong. Except the metals like sodium and potassium. These metals are so soft that we can easily cut them with a knife. So this is a piece of sodium. It is so soft that it can be cut with a knife. So metals are generally hard and strong, except the metals like sodium and potassium, which are very soft. They are so soft that they can be cut with a knife. Now what about the non-metals? A form of carbon is diamond. Diamond is a form of carbon which is the hardest known substance. So this is the hardest known substance. So we know it is hard. But other non-metals like sulfur and phosphorus, they are very soft in nature. So non-metals can be both hard or soft. This is an aluminium block which is used in industries. It exists in the form of big blocks. But you must have seen the aluminium foils the aluminium sheets or the tin sheets which are used at home. So from an aluminium block, we can get very thin aluminium sheets. So this property of the metals, according to which we can beat them into very, very thin sheets, is known as malleability. So malleability is the property of the metals due to which they can be beaten into very thin sheets. So in this, the metals can be beaten into very thin sheet. Such a property of the metals is known as malleability. From a big block of aluminium, we can get very thin sheets of aluminium as well. So this property of metals is known as malleability. But in this again, we have two exceptions, zinc and mercury. We know mercury is in the liquid state, so we cannot beat that into sheets. Zinc is a metal which cannot be beaten into sheets. So these are the only two exceptions. Rest all metals can be beaten into thin sheets. But what happens when you try to beat or shape coal? Do you think you would be able to shape coal in whatever manner you want? No, you cannot. Because as you start shaping it, you see that it breaks. So we cannot shape the non-metals. So the non-metals are non-malleable. That is, they break into pieces. And this property, according to which they break into pieces, is known as the brittle nature of the non-metals. So the non-metals are non-malleable. That is, we cannot beat that into sheets as they break into pieces. And this property, according to which they break into pieces, is known as the brittle nature of the non-metals. So they are not malleable, instead they are brittle in nature. Now, this is how copper exists in the form of big blocks again, and there are big blocks of gold as well. So now from this big huge copper block, we can get very thin copper wires. Observe. So in this, there is a considerably thicker copper block. And this can be used to form really, really thin copper wires. So such property of the metals, according to which they can be drawn into really thin wires, is known as the ductility of the metals. So from a big block, we can get very thin wires of the metals. Such property is known as ductility. So ductility is the property according to which the metals can be drawn into really thin wires. Gold is the most ductile metal. From just 1 gram of gold, we can make a 2-kilometer long gold wire. So gold is a very ductile metal, and ductility is the property due to which the metals can be drawn into very thin wires without breaking. Again, we have two exceptions as we had for malleability, that is zinc and mercury. Mercury in the liquid state, we cannot draw it into wires, and at the same time zinc cannot be drawn into thin wires. Rest all metals can be beaten into thin sheets, that is they are malleable, and they are ductile, that is they can be drawn into very thin wires. What about the non-metals? Have you ever heard of a coal wire? No, you haven't, because again, non-metals are brittle in nature. We cannot shape them. So we cannot draw wires from the non-metals, so they are not ductile. Radha had a piece of an element. She had to find out if it was a metal or a non-metal. She observed that when she tried to hammer the piece to make a sheet, it broke into small pieces. So now what did she conclude? Is it a metal or a non-metal? So when she tried to hammer it, she observed that the metal broke into small pieces. We know metals are generally malleable and ductile. They can change the shape without breaking. But the non-metals are brittle in nature. We cannot change the shape because as we try to change the shape, they break into pieces. So non-metals are generally brittle. So the element piece that she had was non-metallic. So Radha actually had a non-metal with her. Now the utensils that you use for cooking. These are steel or iron utensils. Why do we use metallic utensils? Because they have to transfer heat to the raw vegetables that we keep inside. So they easily transfer the heat to the raw vegetables inside, and this is how cooking takes place. Similarly, the base of the press, it is made up of iron metal. Now again, in this case, the metal easily transfers the heat from the press to the clothes, and hence this is how we press the clothes. And the copper or aluminium cables. These are the cables which are used for the conduction of electricity. So we have seen that metals are generally very good conductors of heat and electricity. This is why we use them for different purposes, for the conduction of heat and electricity. But what about non-metals? Have you ever heard of a coal electric cable? No, you haven't. This is because non-metals are poor or non-conductors of heat and electricity. So non-metals are not good conductors. Instead, they are poor conductors of heat and electricity. Now, you drop a metal coin on a floor and simultaneously drop a coal piece on floor. Do you think there will be any difference? Let's see. You drop a metal coin and you drop a coal piece. So if you hear, there is a very peculiar and prominent sound which you hear when you drop a metal coin. But that is not observed when you drop a coal piece. So this sound, which is associated with the metals, is what we call sonorous. So metals are generally sonorous as they produce a prominent and peculiar sound, and non-metals are generally non-sonorous. That is, they do not produce this peculiar and prominent sound. And this is the reason why the bells at schools, in temples, they're all metallic in nature. So these bells are metallic, that is, they are sonorous, and so they produce the sound. This peculiar sound that you hear is because the metals are sonorous in nature, and so they are used to make bells. So now let's compare the physical properties of the metals and non-metals. Metals, the physical state of the metals we know metals are generally solid at room temperature. Non-metals can be solids or gases. For example, coal is a solid, and oxygen, nitrogen, etc., they are all gases. The metals are generally hard and strong, so gold, platinum, etc. And non-metals can be hard like diamond, and they can be soft like sulfur and phosphorus. So they are both hard or soft. Malleable. We know we can easily beat the metal into thin sheets, but when we try to do that for non-metals, they break into pieces. So non-metals are non-malleable. From metals, we can get very thin wires, so the metals are ductile. Non-metals, again, we cannot shape them to form thin wires, so non-metals are non-ductile. Metals we use for making the utensils, for the electric cables. So metals are good conductors of heat and electricity. Non-metals are poor conductors of heat and electricity. And metals produce a peculiar prominent sound, so they are sonorous in nature, and non-metals are non-sonorous. So these are some of the physical properties of metals and non-metals.